Hey guys, so as promised, we're continuing the IGCSE mensuration questions. We're now on the hot questions, which are the most advanced questions where students struggle the most. So if you're someone who's new to this channel, I started this series where I did different levels of mensuration questions, starting with the mild, which were the easy ones. Then we did the spicy ones, which were the medium ones, and then advanced hot ones. So right now we're at the hot ones. So these questions will greatly help you in understanding mensuration and make you understand how to solve these questions and how to correctly apply the formulas when needed. If you're someone who's still struggling with the mild ones and the spicy ones, I'm attaching the link above, and you can check those questions out and develop better understanding of your basics. So let's start with the hot questions now. This question says the diagram shows a triangle ABC with point G inside. CB is 11 centimeters, CG is 5.3 centimeters, and BG is 6.9 centimeters. Angle CAB is 42 degrees and angle ACG is 54 degrees. We have to calculate the value of x. So now if we look at the triangle BCG, in this triangle we have all three lengths and they want us to find one of the angles. So whenever we have all three lengths in a non-right angle triangle and they want us to find the missing angle, we use the cosine rule. So for this, the cosine rule is going to be cos of x equals to 11 square plus 5.3 square minus 6.9 square divided by 2 times 11 times 5.3. When you solve this fraction, what we get is 0.87032. So x is going to be cos inverse of this, and that's going to give us 29.5 degrees. That is your value of angle x. Then it says calculate AC. So to calculate AC, if we highlight the triangle, this is AC. So we already have the entire angle C, which is going to be 54 plus 29.5. We have angle A. We have the length of CB, which is opposite of angle A. So if we find angle B, we can easily find AC using the sine rule. In the sine rule, we need one complete set of angle and length. First, let's find angle B. That's going to be 180 minus 42 minus 54 minus 29.5. That's going to give us 54.5 degrees. So now, since we need to find AC, so it's going to be AC over sine of angle B, because that's the angle that is opposite to length of AC. And this equals to 11 over sine of 42. Because CB, the length is opposite to the angle A, which is 42. So it's going to be AC over sine of 54.5 equals to 11 over sine of 42. Cross multiply, so 11 times sine of 54.5 divided by sine of 42. And AC is going to equal 13.38 or 13.4. That is your length of AC. Then it says water flows at a speed of 20 centimeters per second along a rectangular channel into a lake. The width of the channel is 15 centimeters. The depth of the water is 2.5 centimeters. Calculate the amount of water that flows from the channel into the lake in 1 hour, giving your answer in liters. So we have to calculate the amount of water that is flowing from the channel into the lake in 1 hour. So basically, we need to find this distance first. And using this distance, we will find the volume of water that is coming into the lake in 1 hour. So we have the speed, which is 20 centimeter per second. First, we need to convert so since the time is 1 hour, let's convert the hour into seconds because the speed is in centimeter per second. So 1 hour equals to 3600 seconds. So this distance is going to be speed times time. Now the speed at which the water is flowing is 20 centimeter per second, and the time in seconds is 3600. So 20 times 3600 is going to be 72,000 centimeters. That is this distance. Now, to calculate the amount of water that's flowing, that's basically the volume of the water, because the units are liters. So it's going to be 2.5 times 15 times 72,000, and that is going to give us 2,700,000 centimeter cube. They want the answer in liters. So 1 liter is 1,000 centimeter cube. So this in liters is going to be 2,700,000 divided by 1,000. And that is 2,700 liters. So that's your answer. Question 5, it says the diagram shows a field ABCD. The bearing of B from A is 140 degrees. C is due east of B and D is due north of C. AB is given as 400, BC is 350 meters, and CD is 450 meters. We have to find the bearing of D from B. So if we connect D and B, and we draw the north at B because we need to find the bearing from B. So bearing of D from B is this angle. This is what we need to find. If you notice, this is a right angle triangle because C is due east of B. So we have the adjacent, we have the opposite. So we can easily find this angle, subtract that from 19, then find the bearing. So for this angle, we'll use tangent. Tan theta equals to opposite, which is 450, divided by the adjacent, which is 350. So theta is tan inverse of 450 divided by 350, and that is going to give us 52.13 degrees. So then the bearing of D from B is going to be 90 minus 52.13, which equals 37.87 degrees. So we add a 0 over here because the bearing cannot be 2-digit. It has to be 3 digits below. It has to be 3 digits before the decimal. So 037.87 degrees. That is your bearing. Then it says calculate the distance from D to A. So to calculate the distance of D from A, we know that this is 52.13. We can easily find this angle by subtracting 90 and 2.13 because this was a right angle triangle. So angle BDC is 90 minus 52.13, which was 37.87. So this is 37.87 degrees. We have to find this distance, AD, this is X. So we have this length. BD square is going to be 450 squared plus 350 squared. So that's 325,000. Square root that, and that gives us 570.08 meters. That is BD. So 570.08. So now we know that the bearing of B from A is 140. So if you draw the north over here, this angle is 140. This is a 90. So we can easily find this angle over here by subtracting all of these angles from 360. So angle ABD is going to be 360 minus 140 minus 90 minus 52.13. Now the reason why this angle is 140 is because both the norths are parallel, the north at A and the north at B. So in parallel lines, alternate angles are equal. This 140 is alternate to this angle. So this is why this is 140. Since B and C are on a straight horizontal line, because C is due east of B. So that means we're going straight from B to C. So that gives us a 90-degree over here. 52.13 was already calculated in the previous question. So 360 minus 140 minus 90 minus 52.3, 2.13 gives us 77.87 degrees. So now we have the angle over here. This is 77.87. So if you notice in triangle ABD, we have two lengths and the angle between them, which means to find the third length, we can easily use the cosine rule. So AD square is going to equal to 400 squared plus 570.08 squared minus 2 times 400 times 570.08 times cos of 77.87. That is going to give us 389,158.249 square root both sides. AD will equal 623.8 meters. That is your value of AD. Then it says, Jono runs around the field from A to B, B to C, C to D, and D to A. He runs at a speed of 3 meters per second. Calculate the total time he takes to run around the field. Give your answer in minutes and seconds correct to the nearest second. So we're going from A to B, B to C, C to D, and then D to A. Speed is 3 meters per second. They want to give the time in meters per second. So we found AD to be 623.8 meters. The total distance is going to be 400 plus 350 plus 450 plus 623.8. That is going to give us 1,823.8 meters. Time is going to be distance divided by speed, which is 1,823.8 over 3, 607.93 recurring. This is in seconds. They want in minutes and seconds. So if we divide this by 60, that gives us 10.132. So time in minutes would be 607.93 recurring divided by 60, which is 10.132 minutes. So if we multiply the 0.132 with 60, that's going to give us 8. So it's going to be 10 minutes and 8 seconds. Remember, you multiplied the numbers after decimal by 60 to convert the 0.132 recurring into seconds, and that is 8 seconds. So 10 minutes and 8 seconds is your answer, correct to the nearest second. For seconds, you would be getting 7.93 recurring. So 7.93 is down to the nearest second, which is 8. Hence, it's 10 minutes and 8 seconds. Question 8 says that triangle ABC is mathematically similar to triangle PQR. The area of triangle ABC is 16 centimeters square. Calculate the area of triangle PQR. So for this, the formula is very simple. Length of A, I'm going to call this shape A. I'm going to call this shape B. Length of A over length of B squared equals to area of A over area of B. So that's 8 over 12 squared equals to 16 over area of B. So that's 2 over 3 if we simplify the 8 over 12. Squares, that's 4 over 9. So area of B is going to be 16 times 9 over 4, which is basically equal to 1s are 4. 4 times 4 is 16, so that's 36 centimeters square. That is the area of triangle PQR. Then says the triangles are the cross sections of prisms which are also mathematically similar. The volume of the smaller prism is 320 centimeter cube. Calculate the length of the larger prism. So the volume of the smaller prism is 320 and the area of the smaller prism was 16. Length of smaller prism would be, let's find that first, 320, which is the volume, divided by the cross-section area, which is 16. That equals to 20 centimeters. Now for the smaller prism, the length was 8. And for the larger prism, the length was 12. So what was the scale factor? Scale factor over here was 12 over 8, which is 3 over 2. That was scale factor. So if the lengths were being increased by the scale factor, so that means your longitudinal length for the entire prism would also be increased by that length. So if the smaller prism has the length of 20 centimeters, length of larger prism would be 20 times 3 over 2, which is 3 times 10, and that's 30 centimeters. That is the length of the larger prism. So remember, in such cases, if they've just given you like very minimal information and they still want you to find the other length of the shape, scale factor is the same for all sides of the shape. So if you figure out the scale factor for one set of sides, the same scale factor will be used to enlarge the smaller length of the prism to get the larger length. So we use the scale factor, multiply that by the length of the smaller prism, and that gives us the length of the larger prism. Part B says cylinder with radius 6 centimeters and height 8 centimeters has the same volume as a sphere with radius 4.5 centimeters. Find the value of H. So if they have the same volume of sphere is going to be 4 over 3 pi r cubed, so 4.5 cubed. That gives us 381.703 centimeter cube. So this is the same as the volume of the cylinder. So you put the value equal to the volume for the cylinder formula, pi r square h. So 381.703 equals to pi times 6 square, because that's the radius, and height is h. So 381.703 will be divided by 36 pi to get the height, and that gives us 3.37 centimeters. That is your answer. Then it says a solid metal cube of side 20 centimeters is melted down and made into 40 solid spheres, each of radius r centimeters. Find the value of r. So since it's a metal cube, that means all sides are 20. So volume of cube is going to be 20 times 20 times 20, which is 8,000 centimeter cube. So this cube is melted to make 40 solid spheres, each with a radius of r centimeters. We have to find the value of r. So volume of sphere is 4 over 3 pi r cube. So 4 over 3 pi r cube. So 8,000 is equal to 40 times 4 over 3 pi r cube. Once again, one metal cube is melted to make 40 small solid spheres. That's why we have to multiply the volume of the sphere with 40. So that's 8,000 times 3 cross multiply equals to 160 pi r cube. Divide both sides by 160 pi to isolate r cube. That's going to give us 47.746 equals to r cube. Take the cube root on both sides, and that equals to 3.62 centimeters. That's your answer. Then a solid cylinder has a radius x centimeters and height 7x over 2 centimeters. The surface area of a sphere with radius r centimeters equal to the total surface area of the cylinder. Find an expression for r in terms of x. So they both have the same surface area. So surface area of sphere is going to be 4 pi r square. Surface area, total surface area of the cylinder is going to be 2 pi rh plus 2 pi r square. So that's 2 pi x times 7x over 2 plus 2 pi times x squared. So if we simplify this, that's 7 pi x squared plus 2 pi x squared, which becomes 9 pi x squared. 4 pi r squared is equal to 9 pi x squared because they're equal. So they want an expression for r in terms of x. R squared equals to 9 pi x squared over 4 pi. The pi's get cancelled out. And r equals to square root of 9x squared over 4, which is 3x over 2. That is your expression for r. Question 3 says the diagram shows a prism. The cross section of the prism is a trapezium with CD parallel to AB and AC is equal to BD. This length is equal to this. And these two are parallel. AB is given as 10 centimeters, CD is 4 centimeters, and the height of the trapezium is 5 centimeters. So 5 is our perpendicular height. The volume of the prism is 525 centimeter cube. The prism is made of iron. 1 centimeter cube of iron has a mass of 7.8 grams. Calculate the mass of the prism. Give your answer in kilograms. So if 1 centimeter cube is equal to 7.8 grams, 525 centimeter cube would be 525 times 7.8, which is equal to 4,095 grams. So in kg, we're going to divide this by 1,000, because 1 kg equals to 1000 grams. So that's going to be 4.095 kilograms. That's your answer. Then it says calculate the length of the prism. So for the length, they're talking about this part. This is what we need to find. So we said these two are equal, these are equal, and this is 5. So they've given us the volume, which is 525. If you find the cross-section area times the length is always equal to the volume. So using that, we can easily find the length. Area would be cross-section area would be 1/2 times the height, which is 5, then times the sum of parallel sides, which is 4 plus 10. So that equals to 1/2 times 5 times 14, which is 35 centimeters square. Volume is cross-section area times the length. So that's 525 equals to 35 times x. 525 divided by 35 is going to give us the length, which is 15 centimeters. That is the length of the prism. Then it says calculate the total surface area of the prism. So for the total surface area, if you remember the shape, we have a trapezium at the front and back. And then we have a rectangle at the top, at the bottom, and on the sides. These lengths were equal. This was 4, this was 10, and this was 5. And this we found out to be 15. So total surface area, we need to find the area of all of the sides. So for the trapezium, we found the area to be 35. So 35 times 2, that's 70 centimeters square. That's area of the front and the back face. Then for the sides, we need to find the slant length. For the slant length now, since both the sides are equal, that means it's a symmetrical shape. So if this is 4, this middle part is 4, and this is 3, and this is 3. This would add up to 10, because 3 plus 3 is 6, 6 plus 4 is 10. This is a right angle triangle. So using this right angle triangle, we can find the slant length with Pythagoras. So we call this x. X square equals to 5 square plus 3 square. 25 plus 9. 34. Square root both sides. X is going to be 5.83 centimeters. So area of the sides is going to be 5.83 times 15 times 2, because there are two sides. 174.9 centimeters square. Then area of the top would be 4 times 15, which is 60. Area of the bottom would be 15 times 10, which is 150 centimeters square. So total surface area is going to be the sum of all of these. 70 plus 174.9 plus 60 plus 150, which gives us 454.9 centimeter square. That is your total surface area of the prism. Then it says in a mathematically similar prism, the height of the trapezium is 10 centimeters. Calculate the volume of this prism. Since both the prisms are similar, I will talk about the volume of the new prism. So length of the new prism divided by length of the old prism cubed equals to volume of the new prism divided by volume of the old prism, which was 525. So 10 divided by 5 is 2. 2 cube is 8. So 8 times 525 equals to the volume of the new prism. And that's going to be 4200 centimeter cube. That's your answer. Then it says a cuboid measures 10 centimeters by 4 centimeters by 6 centimeters. Each side is measured correct to the nearest centimeter. Complete the inequality for the volume V of this cuboid. So if each side is measured correct to the nearest centimeter, that means the degree of accuracy is 1. So 1 divided by 2 is 0.5. So for the upper bound of these measurements, we're going to do 10 plus 0.5, then 4 plus 0.5, and 6 plus 0.5. They basically want to find the upper bound and lower bound of the lengths and then use that to find the upper bound and lower bound of the volumes. So that's 10.5 centimeters, 4.5 centimeters, and 6.5 centimeters. Now for the lower bound, we do 10 minus 0.5, 4 minus 0.5, and 6 minus 0.5, which is 9.5 centimeters, 3.5 centimeters, and 5.5 centimeters. So upper bound of volume would be 10.5 times 4.5 times 6.5, which is 307.125 centimeter cube. And lower bound of volume would be 9.5 times 3.5 times 5.5, which gives us 182.875 centimeter cube. So it's smaller than 307.125 and bigger than 182.875. That is your answer. Question 7 says, diagram shows a container for storing grain. The container is made from a hemisphere, a cylinder, and a cone, each with radius 2 meters. The height of the cylinder is 5.2 meters and the height of the cone is h meters. Calculate the volume of the hemisphere. Give your answer as a multiple of pi. So for the volume of the hemisphere, we will do 2 over 3 pi r cube because half of 4 over 3 pi r cube. Radius is 2 centimeters. So 2 over 3 pi times 2 cube. And that's going to give us 16 pi over 3 meter cube. Then it says the total volume of the container is 88 pi over 3 meter cube. Calculate the value of h. So for the total volume, there's a hemisphere, there's a cylinder, there's a cone. So for the hemisphere, we already found the volume, which was 16 pi over 3. For the cylinder, it's going to be pi 2 square times 5.2. So 5.2 times 4, that's 20.8 pi. And what's it called? The cone, 1 over 3 pi r square h. So 1 over 3 pi times 2 square times h, which is 4 pi over 3h. So sphere is 16 over 3 pi. So 88 pi over 3 equals to all of these added 20.8 pi plus 4 over 3 pi h plus 16 over 3 pi. So 88 over 3 pi minus 20.8 pi minus 16 over 3 pi equals to 4 over 3 pi h. So if we solve these, on the left-hand side, we'll get 3.2 pi. So you can cancel the pi's on both sides. And we have 3.2 times 3 over 4 equals to the height. And that is going to give us 2.40 meters for the height. That is your answer. When the container is full of grain, grain is removed from the container at a rate of 35,000 kgs per hour. 1 meter cube of grain has a mass of 620 kgs. Calculate the time taken to empty the container. Give your answer in hours and minutes. So we know the entire volume of the, what's it called? The solid, which is 88 over 3 pi. Meter cube. They said that 1 meter cube of grain has a mass of 620 grams, 620 kgs. So the container removes the grains at the rate of 35,000 kgs per hour. So first we find the total mass of the grains in the container. So total mass would be the volume times the weight of 1 grain. That is going to give us 57,135.098 kgs. The rate at which the grain is being removed is 35,000 kg per hour. So 35,000 is basically equal to 57,135.098 divided by time in hours. So time is going to be these two being divided. That is going to give us 1.6324 hours. They want the time in hours and minutes. So the numbers after the decimal. So basically 0.6324 gets divided by 60 to convert it into minutes. So 0.6324 times 60 is approximately 37.94. So we round that to 38. So that's 1 hour and 38 minutes. So remember, you multiply the 0.6324 with 60 to convert into minutes, and the number before the decimal, that's your hours. Part B says A and B are points in a circle, center O, radius R centimeters. The area of the shaded segment is 65 centimeters square. Calculate the value of R. So this is a 4-mark question. So for this, we know that OA and OB are equal because they're the radius, so both of them are R. We have the area of the shaded segment, 65 centimeters square. So shaded segment is basically equal to the difference of the area of the sector and the area of the triangle OAB. Area of the sector is going to be 140 over 360 times pi r square minus 1 over 2 times r square times sine of 140. This is the area of the triangle. So if we rewrite the fractions in decimals, 140 divided by 360 times pi is 1.2217 r square. And sine 140 divided by 2 is 0.3214 r square. Subtract the two, 1.2217 minus 0.3214, 0.9003 r square. Divide the two, square root the result. So r is going to equal to 8.49 centimeters. That's your radius. Question 9 says a rectangle has a perimeter of 20 centimeters. Find the value of x. So 20 equals to the sum of all of these lengths. Opposite lengths are equal in a rectangle. So x plus twice of x plus 3. That is 20 equals to 2x plus 2x plus 6, which is 4x plus 6. Bring the 6 to the other side. So 20 minus 6 equals to 4x. 14 equals to 4x. Divide both sides by 4. And x is going to equal to 3.5 centimeters. That's your answer. Then it says this rhombus has a perimeter of 20 centimeters and angle y is obtuse. M is the midpoint of one of the sides. Find the value of y. So in a rhombus, your opposite angles are equal and all sides are equal. So if the perimeter is 20, 20 equals to 4 times x, and 5 centimeters would equal to x. So that means all of these lengths are equal to 5. And since M is the midpoint, this is 2.5, this is 2.5. So over here, we know that if this is y, this is also y. If you notice, in this triangle, we have one complete set of angle and length. We have angle 20, we have the opposite length 2.5. So using that, we can find the angle for M and then subtract these two from 180 to find angle y. So it's going to be, if we call this x over here, this angle. So 2.5 over sine of 20 equals to 5 over sine of angle x. So that's going to be sine of angle x equals to 5 times sine of 20 over 2.5. Sine x equals to 5 sine 20 divided by 2.5. That's 0.68404. So x would be sine inverse of 0.68404. And that's going to give us 43.16 degrees. So y is going to be 180 minus 43.16 minus 20. And that gives us 116.84 degrees. That is your angle y. Part C says this sector of a circle has radius r and perimeter of 20 centimeters. Find the value of z. So if this is r, this is also r. And perimeter is basically 2r plus arc length. So we can find the arc length because we have the angle. So that's going to be 40 over 360 times 2 pi r. So that's 20 equals to 2r plus 2 pi r over 9. 20 equals to 18r plus 2 pi r over 9. Cross multiply. That's 180 equals to 18r plus 2 pi r. 180 would be divided by 18 plus 2 pi, and r would remain over here. So 180 divided by 18 plus 2 pi, that's r equals to 7.41 centimeters. So this is 7.41. This is 7.41. If you notice, we have two lengths and the angle between them. I have to find the third length, which means we use the cosine rule. So z squared equals to 7.41 squared plus 7.41 squared minus twice of 7.41 being multiplied and then times cos of 40. That's going to give us 25.69 square root both sides. So z is going to be 5.068 centimeters. That is your answer. Question 8 says a solid cube measures 20 centimeters by 12 centimeters by 5 centimeters. Calculate the volume of this cuboid. So volume is simple. You multiply the length with the width and height. It's going to give us 1200 centimeter cube. Then it says calculate the total surface area of the cuboid. For total surface area, we do 2 times 20 times 12 plus 2 times 12 times 5 and then plus 2 times 5 times 20. Why? Because if we draw the cuboid, this is 20, this is 5, this is 12. So bottom part would be 20 times 12 twice, then front and back 5 times 12 twice, and then your left and right, that's going to be 5 times 20 twice. So that's going to give us 800 centimeters square. Then part B says the surface of the cuboid is painted. The cost of the paint used is $1.52. Find the cost to paint 1 centimeter square of the cuboid, giving your answer in cents. For 1 centimeter square, we do 1.52 divided by 800, which gives us $0.0019. So in cents, we're going to times it by 100. That is 0.19. And that's your answer. Part B says a solid metal cylinder with radius x and height 9x/2 is melted. All the metal is used to make a sphere with radius r. Find r in terms of x. So a solid metal cylinder with the radius x and height 9x/2 is melted. So volume of the cylinder is going to be pi r square times the height. So that's 9 pi x cube over 2. This is melted to make a sphere with radius r. So volume of the sphere is 4 over 3 pi x cube. Put both of them equal to each other because the cylinder is melted to make the cube. So that's 4 pi x cube over 3. This is r square, not x square. R cube, sorry. This is also r cube, yeah. Okay, so find r in terms of x. So we need to make r the subject. So 9 pi x cube over 2 times 3 over 4 pi equals to r cube. So that's going to give us 27x cubed over 8, cube root both sides, and r is 3x over 2. That is your expression of r in terms of x. Then part C says the diagram shows a cylinder of length 150 centimeters on horizontal ground. The cylinder has radius 20 centimeters. The cylinder contains water to a depth of 5 centimeters as shown in the diagram. Calculate the volume of water in the cylinder giving your answer in liters. So the depth of the water is 5, the length of the cylinder is 150, and the radius is 20. You need to remember that radius is this as well. As long as the distance is coming from the center and going towards the circumference, it's the radius. So this is entirely 20. So this top length is going to be 15 because the bottom part is 5. To find the volume of the water in the cylinder, we need to find this cross-section area, the cross-section of the water. So connect this and we can see that we have a sector. And inside the sector, we have the shaded part is the water and the top part is a triangle. So if we subtract the area of the triangle from the area of the sector, you can find the area of the water, which is the cross-section area for this part. And then we times it by 150 to get the volume of the water. So let's start with finding the area of the water or cross-section area of water. So that's going to be area of sector minus area of the triangle. Area of sector is going to be, we don't know the angle for the sector. To find the angle of the sector, first we need to find this angle. So we know if this is 20, this is also 20. And actually, no, we can use Pythagoras. You don't need to use cosine. So I'm going to draw the triangle over here. This is 20. This height was 15. And we need to find this angle. So this is a right angle triangle. We can use SOHCAHTOA. So we have the adjacent, we have the hypotenuse. This is the angle. So cos theta equals to 15 over 20. Theta would be cos inverse of 15 over 20. And that's going to give us 41.41 degrees. So total angle of sector would be 2 times 41.41, which is 82.82 degrees. So for the cross-section area of water, we do the area of sector minus area of the triangle. So now that we have the angle, we can do 82.82 divided by 360 pi r being 20 squared minus 1 over 2 times 20 squared times sine of 82.82. I'm going to separate this area so that doesn't get jumbled up. So that's going to give us 82.82 times pi, then times 400, then divided by 360. That's 289.096 minus 400 sine of 82.82 divided by 2. That's 198.431. So 289.096 minus 198.431 is 90.67 centimeters square. That is the cross-section area of water. So volume of water is going to be the cross-section area times the length. So 90.67 times 150, and that's going to give us 13,600.5 centimeter cube. So for the answer in liters, we divide this by 1,000. That's going to be 13.6 liters. That's your answer. Question 8, it says that a cuboid has length L centimeters with width W centimeters and height 8 centimeters. The diagram shows the net of this cuboid. The ratio W is to L is 1 is to 2. Find the value of L, the value of W, and the value of H. So W is to L is 1 is to 2. That means the length is twice the width. This is also L. This is W. All of these are W. This is L. This is also L. This is also L. This is H. This is also H. This is also H. And these are also H. These are also H. Okay. So if width is X, length is 2X. 37.8 equals to 2 lengths and 2 heights. This length, height, height. And 20.1 equals to 2 heights and 1 width. So over here, if we make 2H the subject, 20.1 minus W equals to 2H. Substitute this in the first equation. So that's going to be 37.8 equals to 2L plus 20.1 minus W. Take the 20.1 to the other side. So it's a 7.8 minus 20.1 equals to 2L minus W. 17.7 equals to 2L minus W. We said that W is X, so L is twice of X. So 17.7 equals to 2 times 2X minus X. So that's 4X minus X, and 17.7 equals to 3X. So 17.7 divided by 3 is 5.9 centimeters. That is X, so which is W. L would be twice of X, so twice of 5.9, which is going to give us 11.8 centimeters. And for H, we can just use these equations. So if we pick this one, 2H equals to 20.1 minus 5.9, which is equal to 14.2. Divide both sides by 2, and H is 7.1 centimeters. These are your values of L, W, and H. Part B says diagram shows a solid pyramid with a rectangular base ABCD. E is vertically above D. Angle EDC and angle EDA equal to 90. AB is 18 centimeters. BC is 15 centimeters and EC is 24 centimeters. The pyramid is made of wood and has a mass of 800 grams. Calculate the density of the wood. Give the units of your answer. They've given us the mass of the wood. We need to find the volume first and then use that to find the density. So for the volume, the formula for the pyramid is 1/3 times area of base times height. So area of base is going to be 18 times 15. And for the area of height, we know this is also 18 and this is also 15 because it's a rectangular base. So using Pythagoras, we can find the length of ED, which is the height. So if I use this triangle, because I have the slant height over here, so we have the hypotenuse, we have the adjacent to find the opposite. So we can use Pythagoras. 24 squared equals to 18 squared plus ED squared. 24 squared minus 18 squared. Square root that gives us ED, which will be 15.87 centimeters. So volume is going to be 1/3 times 18 times 15 times 15.87, which gives us 1428.3 centimeter cube. So density is your mass over volume. Mass is 800 grams. Volume is 1428.3, which gives us 0.560 grams per centimeter cube. That is your answer. Then it says calculate the angle between BE and the base of the pyramid. So BE and the base of the pyramid. So this is the angle. This is the triangle that we're focusing on. This is the angle. So for that, we need to first find this diagonal DB. This is also 15, this is 18, so we can use Pythagoras. DB squared is going to be 15 squared plus 18 squared, which is going to give us 23.43 centimeters. So now we have this. We already have the length of ED, which was 15.87. So for the angle, we use tan. Tan theta equals to 15.87, which is the opposite, divided by the adjacent, 23.43. So theta is tan inverse of this fraction. That's going to give us 34.1 degrees. That's your angle between EB and the base of the pyramid.